There are many ways to solve a quadratic equation. Today we're going to look at how to solve it using factoring. We have an example here of y equals x squared plus x minus 6, and I've also included a sketch of the graph. We've also learned that when you are looking for solutions or roots to a quadratic equation, you're looking for the x-intercepts. And in this case, there are two of them, -3, 0, and 2, 0. So how are these x-intercepts related to the factors of an equation? Well, if we factor this equation, we have x times x gives you x squared, and we're looking for two things that multiply to give you -6 and add up to +1. And that comes out to be x minus 2 and x plus 3. So you'll notice right away, hopefully, that there's a -2 and a +3. And how are those related to the x-intercepts? Well, one of the x-intercepts is -3, 0, and the other one is 2, 0. Now, those are pretty close, except they are opposites. So why is that the case? Well, when we're looking at finding their roots, we're actually trying to figure out where does y equal 0. And in both cases, at -3, y equals 0, and at 2, y equals 0. And that makes sense, because what would I have to multiply on the right side of this equation to get 0? Well, one of these factors would have to equal 0. So is it the first one? Or is it the second one that equals 0? This is called the zero product property. And basically it says if I have two factors and multiply to give me 0, one or both of them must equal 0. And so if I'm going to solve each one of these, x equals 2, subtract the 3 over here, x equals -3, and there you have your solution to that equation. Now you can think about it too. If you plug in a 2 into this factor here, 2 minus 2 is 0, and that's what would give you a factor of 0, which would make y be 0 as well. And so we're going to use this idea where we don't have to look at the graphs anymore. We can just take an equation and we can solve it by factoring it. So let's look at another example. Let's look at something like 8 equals x squared plus 2x. Well, first thing we want to do is set it equal to 0, so we're going to subtract an 8 from both sides. And now we're just going to factor it. So I need two factors that multiply to give you a -8, and then add up to a +2. And that comes out to be 4 and 2, +4, -2, and that should give you the factor form. Now we're not finished yet. We just have to set each of the factors equal to 0. So this one we're going to subtract a 4, and this one we're going to add a 2. And so our solution would be 2 and -4. What we actually figured out here was this is where your graph crosses the x-axis. These are the x-intercepts. These are the zeros. These are the roots. They all mean the same thing. These are the solutions. All of those words mean the same thing. So let's go to another example. So it's a little bit more challenging to factor this one. However, we can still do it. I know this time it has to be 2x times x to give you the 2x squared in the front. And now I need two other numbers that when I do FOIL, I get a -5 on the end and negative 9 when I add the inner and outer terms together. And that looks like it comes out to plus 1 and minus 5. That should work. 2x squared minus 10. X plus 1x gives you a negative 9x and a negative 5. So how is this one different? Not really any different, except now when we solve on this one we have 2 steps. So we're going to subtract a 1 and divide by 2 to get x by itself. Over here we're going to add a 5 to both sides. And so this time we get a fraction, which is fine. Our graphs can cross the x-axis at fractions. It doesn't have to be whole numbers all the time. So our solution would be negative 1/2 and 5.